This is very important. This is a question. This is not a topic. Let me tell you. This is not a topic. This is a question, because you can notice that new variations can be created. So I will solve 7 or 8 variations now. Okay. And these are very interesting. So you can take your copy pen. All of them you will do. Okay. So these are the alternative definition of abelian group. Remember, these are alternative definitions of abelian group. Means these are if and only if statement. All the statement that we will see from now onwards, these are alternative definitions of abelian group. Tell me, if you want to say that a group is abelian, what you need to do? What is the definition you know for abelian group? What is the definition that you know? Abelian group. It means a group with commutative property. A group with commutative property. A group with commutative property. With commutative property. And what is commutative property? What is commutative property? Commutative property means AB equal to BA for all A comma B. So this is the idea. Now, if I give you anything, now remember, this is what you need to do. If I ask you whether a group is, okay, if I ask you, okay, if I ask whether a group is abelian or not, if I ask whether a group is abelian or not, group is abelian or not, then what you need to do? What is your target? If a group is abelian, then what will be your target? What is your target? What do you want to prove? Your target. Your target is AB equal to BA. Remember, your target will be AB equal to BA. Okay, this is your target. So remember, keep this target in your mind. So if I ask you whether a group is abelian or not, this is your target. Now let's start the questions. And to achieve this target, what is the method you will apply? Do you remember I told you in group theory, we have only one proof method. Multiply both sides by inverse or apply the definition. Okay, very simple. Definition or inverse, multiply with inverse. So let's start with the question number 1. If you have a group G, and let's assume this happens for all A comma B, if this happens, A star B inverse is equal to B inverse A inverse, then can I say G is abelian? Then G is abelian. Can I say G is abelian? If this happens, then G is abelian? The answer is no. This will happen in every group. This is the property of group. The answer is no. This is the property of group. This will happen in every group. This is a property of every group. This is property of every group. Every group. Okay. Like don't see, just because I'm teaching you abelian group, does it mean every answer will be abelian? Okay, this happens. I know many times this happens. Just because I'm teaching you abelian group, it does not mean that it will be abelian. Okay. So anyway, remember, this is the property of every group. Whatever group you take, this will be the property. This property will be there. So this is not correct. Now let's see question number 1. Sorry, question number 2. If you have a group with this property, then can I say it must be abelian? The proof is very simple. Can you do it? If G is a group such that this happens for all A comma B, then can you say that AB equal to BA? What is the proof? Then it will be, remember, this is a group. You know that you have a group G. Okay, and for all A comma B, AB square is equal to A square B square. What we need to prove? What is our target? What is our target? Our target is AB equal to BA. This is our target. Can you achieve this target? Yes, very easily you can achieve, because AB square equal to A square B square. It means AB is equal to AABB. Now what you can do? Multiply by A inverse. Now very simple. Multiply by A inverse, and on RHS multiply by B inverse. So just put it between A inverse, B inverse. Put it between A inverse, B inverse. So multiply both sides by A inverse. Multiply both sides by A inverse. and multiply both sides by B inverse on RHS. This is what you can do because it is a group. Because it is a group, so you can do this. And finally, what this will become, this whole thing will become BA. This whole thing will become BA, and this whole thing will become AB. So BA equal to AB. Isn't it simple? Tell me. Basically, left cancellation. Just do left cancellation. Okay, the idea is left cancellation. If you don't want to do this, then just do the left cancellation. Just do left cancellation. What will happen? Now, left cancellation, what it will give you? Left cancellation. Left cancellation gives you BAB equal to ABB. Now, do the right cancellation. Now, do the right cancellation. If you do the right cancellation, it will give you BA equal to AB. So, abelian. So, this is your proof that this is abelian. So, this is another definition of abelian. Let me tell you. This is another definition of abelian. What it means? It means that a group is abelian if and only if. So, you can notice one thing. So, if this happens, you have a group G. Okay. And for all A comma B, if this happens, means AB square equal to A square B square, then what it implies? It implies what? It implies abelian. It implies abelian. And can I say abelian implies this? Can I say in every abelian group this will happen? Can I say? Can I say in every abelian group this will happen? Can I say in every abelian group this will happen? Yes, of course. If group is abelian, you can notice if group abelian, if you have group G is abelian, if group G is abelian, what it means? It means AB equal to BA. Now what you can do, you can multiply both sides by A. So multiply both sides by maybe B. Okay, so what you can do, you can multiply both sides by B. Now you can multiply both sides by A. So what it means? It means A square B square is equal to AB square. Is this clear? So if your group is abelian, if you know that your group is abelian, abelian means this. This is what abelian means. So if your group is abelian, then what you can do? Then you can multiply both sides by A. Sorry, you can multiply both sides by B. Then you can multiply both sides by A. So finally, this is what we got. A square B square equal to AB whole square. So finally, what I can say this implies abelian and abelian implies this. Is it clear to everyone? So this is also correct. This is also correct. Both sides we have proven. So it means this is the definition of abelian. I can say abelian if and only if. I can say abelian if and only if AB whole square is equal to A square B square for all A comma B. This is the definition. This is a simple question. Did you understand? Let's see question number 2. Okay, so question number next. If every element is its own inverse, then it is abelian. How will you prove it? The information is given to you. Every element is its own inverse. For all elements, okay, I can say it is own inverse. Then can I say abelian? Our target is AB equal to BA. Our target is this, AB equal to BA. This is our target. So tell me, what will you do? Remember, for every element, A inverse is equal to B inverse. And our target is AB equal to BA. This is actually very simple. You can apply this property. AB inverse will be what? In any group. In any group, what will be AB inverse? Tell me. In any group, you have a group. So in any group, AB inverse will be what? AB inverse will be B inverse, A inverse. AB inverse will be B inverse, A inverse. This happens in every group. This happens for every group. For every group, this will happen. Now tell me, that's it. Now for every element, A inverse is A. For every element, now you are saying that, see, AB inverse is equal to B inverse, A inverse. And you are saying that B inverse is same as B, A inverse is same as A. Every element is inverse of itself. This is also inverse of itself. Every element is inverse of itself. Whatever element you take, that is inverse of itself. So I can say this element is also inverse of itself. This AB, this element AB is also inverse of itself. So I can say if every element is inverse of itself, then it is abelian. This statement, can I write in another way? Every element is inverse of itself. How will I write this statement in another way? For all A is equal to A inverse. What this means? Another way of writing. What is the another way of writing? I can say for all A square is equal to E. Yes or no? For all A square is equal to E. Very good, very good. Okay, so this and this, they are same. They are same things. So it means if this is another question you can create. So let's assume you have a group G comma star, and for all A, let's assume A square is equal to E. Then what can I say? Then G is abelian. Then G is abelian. Can I say G is abelian? Then can I say G is abelian? The answer is yes, because you know that A square equal to E, it implies A equal to A inverse for all A. Okay, and we have seen that when this happens, then we have a abelian group. When this happens, then we have a abelian group. Okay. One interesting question. If a group is abelian, okay, this question, if a group is abelian, then can I say this will happen? So if a group is abelian, then can I say for all A equal to A inverse? If a group is abelian, can I say that for all A equal to A inverse? If a group is abelian, then can I say A equal to, for all A equal to A inverse? Tell me. The answer is no. The answer is no. Can anyone give me a counter example? Give me a counter example. Remember the group order 4 template, order 4 template, order 4 template. Give me the order 4 template, U8. Sorry, order 4 template. You can take this order 4 template. U5 you can take. U5. 1, 2, 3, 4. Multiplication modulo 8. Here you can notice this is abelian. You can notice this is abelian because order 4. Because order is 4. So this is abelian. But you can notice that 2 inverse. So order 5. Order 5. This is U5. What is 2 inverse? What is 2 inverse? 2 inverse is 3. 2 inverse is not equal to 2. 2 inverse is 3. So can you notice this? Remember, this is only one way. So these things you have to remember, these things you have to understand, not remember. Don't remember, don't by heart, because in the GATE exam, they can ask you any question, any new question they can ask you. So what I'm saying, if you have a abelian, if this property happens for all A, if A inverse equal to A, then I can say abelian, right? Yes or no? Then I can say abelian. Agree? Then I can say abelian. But abelian does not mean that this will happen. But abelian does not mean that this will happen. So this statement is this statement. Remember, if I give you this statement, a group is abelian. A group is abelian if and only if. If I give you this statement, a group is abelian if and only if for all A inverse equal to A. Is this statement correct? Is this statement true? If and only if a group is abelian, if and only if this happens, the answer is false. This statement is false, and you know the counter example. The counter example, you know, that is U5. If I give you this statement, is this true? If I give you this statement now this is correct. Yes, now this is true. because you know that this is if. If means this will imply this. This implies this. This is true. And if I put only if, then what it means? If I put only if I'm putting, only if it's like this, and this is false. This is a false. Okay, so take care. If and only if. Remember your propositional logic. From propositional logic, you already know P only if Q. This is same as P implies Q. And P if Q. This is same as Q implies P. So P if Q, here this happens. And P only if Q, here this happens. Does every subgroup of abelian group is abelian? Can I say every subgroup of abelian group is abelian? Can I say? This is simple. Just think about it. The answer is yes. Because if you have a abelian group, just think about it. If your group is abelian, then it automatically means that for all a comma b, ab equal to ba. For all a comma b, ab equal to ba. Now, if you take any subgroup, H, then for this subgroup also, what will happen? What will happen here also? For any x comma y, xy will be equal to yx, because operation is same. Notice that operation is same. Subgroup means same operation. You are taking the same operation because operation is same. You are not changing the operation because operation is the same. Yes or no? And you are taking a subgroup. You are taking subset of elements. So it's like you have a G comma star, and what you are doing, same operation you are taking, and you are taking a subset. So every element here, if you take any element a comma b, then that is also here. That implies that is also here. Yes or no? Yes or no? Agree? If you take any two elements a comma b in H, then these two elements are also in G, and the operation is same, and this G is abelian. So this will happen because operation is same, and here also operation is star. So I can say operation is same. So I can say this will happen. So for any elements you take, this will happen. Any element you take, this will happen. So H is abelian. And because G is abelian, since G abelian. Tell me, is this diagram clear? Like what happened? If you take any two elements here, those elements are here also, because H is subset of G. And in G is abelian. G is abelian. So in G, this will happen. And the operation is same. So for those two elements also, this will happen. So this is correct. Every subgroup of abelian group is abelian group. This is question number, this is GATE 2022. What is the answer? GATE 2022. Latest question. What is the answer? Which of the following statements are true? For all a x comma y. So which of the statement? If this happens, then it is commutative. Yes. If this happens, this is two-way. And converse is also true. Vice versa. This is two-way. Remember, this statement is two-way. And this is correct, but this is only one way. This statement is not vice versa. Not vice versa. Not vice versa. If order is 2, then it is commutative. Yes. If it is commutative, then subgroup need not be commutative. No. Subgroup must be commutative. A subgroup of commutative will be commutative, right? Subgroup of abelian will be abelian. Subgroup of commutative will be commutative. Yes or no? So this statement is false. So the answer will be ABC. This is another question. Can you solve it? This is another question. I told you one book. There is a book I told you. In that book, let me tell you, all these questions are there, and by a sequence, all these questions are there in that book, and there are many other questions which has been asked in the GATE exam. They are in that book. I will share that book in the group today. Okay, and I will also mark the questions that have come in the GATE exam. I will mark it. Okay, so you don't have to study that book. Don't read that book, but you just have to check that from that book many questions have come in the GATE exam so far. Like all these questions are in that book already, and there are many other. Tell me about this one. Let G be a group as following. So this property, basically this is, remember, in a group what happens? You already know that in a group left cancellation happens. In group this is allowed. In group what is allowed? AX equal to BX. Then you can do right cancellation, you can do. So A equal to B, this is allowed. And AX equal to AY, you can do left cancellation, this is also allowed. But this is not allowed, right? AX equal to YA. This is not allowed, right? This thing is not allowed. This thing is not allowed. Yes, correct? So this you already know. This is not allowed. Now remember, this question is saying that if this happens, then can I say abelian group? If this happens, then can I say abelian group? Let's prove it. How will you prove it? So if this happens, means xy equal to zx, and this implies y equal to z. If this happens, then can I say that it will be a abelian group? Our target is to prove AB equal to BA. Remember, our target is to prove AB equal to BA. How will I prove? It is very simple actually. It is very not very hard. If xy equal to zx, then it means this. Our target is to prove this, that AB equal to BA. This is our target. So what I can do? I can do something like this. This is correct, right? Remember, this is our target. Remember, this is our target. Our target is this. And I know that I can do something like this. So what I will do? This is my target. AB equal to BA. This is my target. So what I will do? Let me do like this. Are they same? BAB equal to BAB. Are they same? Tell me. BAB equal to BAB. Are they same? Yes, of course. Now, by this property, what you can do? By this property, no, see, they are same. BAB equal to BAB. Yes, because of associative. Very good. Sahana, very good, very good. So because of associative property, this is correct. Because of associative property, we can remove the parenthesis. Now, by this property, I can remove. By this property, I can remove like this. So I got AB equal to BA. That's it. Yes or no? So if you have a abelian group, this is our target, and this is the proof. Isn't it simple? Isn't it simple? Tell me. And can I say if you have a abelian group, then this will happen? So you can notice that if this happens, means if AB, what I'm saying, if you have AX equal to YA, this implies X equal to Y. This thing implies abelian. This thing implies abelian. Can I say abelian implies this thing? Can I say abelian implies this thing? What about this? Yes, abelian will imply this thing, right? This is also correct. Because if you have abelian, then it means AB equal to BA. Okay. And if you have abelian, then what can I do? XY equal to YA. This YA I can write AY. Now I can do the cancellation and I can say X equal to Y. So that is the idea. So I can say this statement is two-way. So because of this, I can say that this statement I can say a group is abelian. A group G is abelian if and only if. This if and only if I can do abelian if and only if for all a comma b, a comma b comma x, ax equal to ba implies x equal to b. Okay, so this is a if and only if statement. Okay, similarly you can do this question. This is also very simple. So what will you do? The question is saying that you can delete in the middle. Now the question is saying you can delete in the middle. Like see, group does not allow deletion in the middle, right? See, in a group, deletion in the middle is not allowed. In a group you can do left cancellation, right cancellation, but you cannot do middle cancellation. In a group this thing is not allowed, like ab, and let's assume for example ab, cd, and let's assume xx. This middle cancellation is not allowed. This middle cancellation, this is equal to ab equal to cd. This thing is not allowed in group. In group this is not allowed. So this middle cancellation is not allowed in a group. But if you can do middle cancellation, then can I say it is abelian? If you can do middle cancellation, can I say it is abelian? If you can do middle cancellation. So what is the proof? So just take something like this. You can do the middle cancellation, right? So just take something like this. Our target is this, but you can do the middle cancellation. Okay, so what I can do? I can do something like this. This is my target AB, and I can do middle cancellation. So something I will put in the middle. You tell me what should I put in the middle so that this is equal. And I should get this. My target is this. I should put A inverse in the middle. If I put A inverse in the middle, then this is same. This is correct. You cannot put identity element in the middle. Don't put identity element in the middle, because we want to prove that you have, see, this is what we want to prove. We want to reach here. We want to reach here. This is here. This is our target. Our target is this. So what should I put in the middle? I should put A inverse. You can check. This is also B. This is also B. Yes or no? Yes or no? This is also B. This is also B. So my target is AB equal to BA. I want to come here. This is my target. So what I'm doing? I'm putting this A inverse in the middle. Now you can notice this is B. You can check this is B. You can check this is B. Now you can do the middle cancellation. And finally you will get AB equal to BA. Target achieved. Yes or no? So if you can do the middle cancellation, then it is a commutative group. And this statement is true. And can I say if you have abelian, can you do middle cancellation? So middle cancellation implies, remember, middle cancellation implies this middle cancellation. This middle cancellation implies abelian. Can I say abelian implies middle cancellation? Can I say abelian implies middle cancellation? If you have abelian, then can I do middle cancellation? So if you have abelian, from abelian, how will you prove that? So if you have abelian, yes, this is correct. Because if you have abelian, then can I do middle cancellation? So let's assume you have this situation, AX equal to B. So let's assume you have this. Then can I do the middle cancellation? Now by associate, if they are equal, let's assume they are equal. Then by commutative, because this is abelian, so by commutative property, I can write it ABX. By commutative property, I can write it CDX. By commutative property, I can use commutative property and I can put them in the, now I can do right cancellation. So AB equal to CD. So if you have abelian, then you can do middle cancellation. Very easy. Yes or no? All these questions, they are very easy. Same thing we are doing, like almost same thing we are doing. Almost same. And this is another. A group is abelian if and only if AB inverse equal to A inverse B inverse. This is where we started. This is also correct. This statement is also correct. So tell me, AB inverse implies A inverse B inverse. Remember, our target is AB equal to BA. Our target is AB equal to BA. So tell me, how will I reach here? My target is AB equal to BA. How to reach? How to reach? This is my target. I want to reach here. So what should I do? You already, yes, very good, very good. Priyanshu, very good, excellent. You already know this is same as B inverse A inverse. It is equal to A inverse B inverse. Now what you can do? Now what to do? Our target is this. Now what to do? Priyanshu? Priyanshu, tell me now what to do? Now what to do? Multiply with A. Just multiply with A. Just multiply with A. If you multiply with A, just multiply with A. Now what you do? Multiply with A. Now just multiply with A. So you will get this. If I multiply with A, B inverse. Oh, wait, so what you can do? See this B inverse A inverse. I can write it as AB inverse. AB inverse same as BA inverse. Yes or no? I can write like this, correct? AB inverse same as BA inverse, right? Yes or no? Because this is AB inverse. You already know this is AB inverse and this is BA inverse. You already know this is BA inverse and you already know this is AB inverse. So I can say that AB inverse equal to BA inverse. Two things have same inverse. Two things have same inverse. What it implies? Two things have same inverse. Two things have same inverse. In a group, inverse is unique. Remember, in a group, inverse is unique. In group, two different elements cannot have same inverse, right? Yes or no? If A is not equal to B, then A inverse is not equal to B inverse. Because inverse is unique. Because inverse of every element is unique. Because inverse of every element is unique. So if you have two different elements, then their inverse also will be different. You already know. So if two elements have same inverse, then they are also same. Because remember, in a group, inverse is always unique. Inverse of every element is unique. So this is the idea. Now one more question. So you know that this happened. So AB inverse equal to A inverse B inverse. This implies abelian group. Okay, for all A comma B, for all A comma B. So this thing implies abelian. Can I say the reverse? Can I say the reverse? Can I say the reverse? Yes, the reverse is also abelian. Because if you have abelian, the reverse is also correct. Because if you have abelian means AB equal to BA, then what you can say? Then because both are same, so their inverse also will be same. Two things are same, then their inverse will also be the same. Two things are same, so their inverse will also be the same. So this means B inverse A inverse, and this means A inverse B inverse. So I can say that AB inverse is equal to, so from here AB inverse is equal to, what is this? This is A inverse B inverse. Okay, so very simple. So this is a two-way. I hope all these points are clear.